Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question number 8, which is from the quadratic relations section. The question says, the height of lava ejected from the Stromboli volcano can be modeled by the relation h equals negative 5t times t minus 11, where h is the height in meters above the volcano and t is time in seconds since it was ejected. So we have another projectile motion quadratic question. So I just like to keep this image in mind, something going up in the air and coming back down in a projectile parabolic shape. So what we have to do is we're going to have to sketch the relation, find the maximum height of the lava, find how long it takes the lava to reach maximum height, and part D is a little strange, is the length of time that the lava is in the air twice the answer for part C. Explain why or why not. So obviously I won't worry about what D is talking about until I get through A, B, and C. So first let's examine carefully the quadratic relation we're given. Here it is, h equals negative 5t times t minus 11. And one thing to notice is that this is already in factored form. So it's a quadratic, but it's in factored form. So when I look at the three tools that we have for dealing with quadratic relations, factor to find the roots, complete the square to find the vertex, or use the quadratic formula to find the roots. Clearly, since this is already factored, I'm going to be using this approach, except for I don't even have to factor. Someone did it for me. So once it's factored, I'll be able to use the roots to find the vertex. So let's go ahead and do that. So in order to find the roots of a quadratic, or of any relation really, we're going to let y equal 0. Because don't forget, the roots are another word for the x-intercepts, and the x-intercepts are where y equals 0. So if I sub 0 in for h, and then I solve. So again, because it's factored, there isn't a lot of algebra I have to do here. It's more like understanding the concept. What I have written here, and I'm going to write it slightly differently, is I have three things multiplied together. I have negative 5 multiplied with t multiplied with this bracket that says t minus 11. So that is three things multiplied together in this equation. Now, we know that anything times 0 is equal to 0, and that's what we want. We want equal to 0. So if any of these three brackets was equal to 0, then I would have a true equation, and the t value that made that true would be a root. So let's look at the first bracket. Is it possible to make this bracket equal to 0? Well, no, that bracket says negative 5. I can't make negative 5 0. It's a constant. I can't touch it. Next bracket. Can I make this bracket 0? Sure. If I let t equal 0, what I have is negative 5 times 0 times negative 11. Well, it doesn't really even matter what's here or here. If this is 0, 0 times anything is 0, and I have a true statement. So one value of t that makes this a true statement is t equals 0. Now let's look at the third bracket, t minus 11. Can I make this into 0? Sure. T minus 11. If I want that to equal 0, I just have to make t equal 11. If I make t equal 11, this bracket is 0. 0 times 11 times negative 5 is still 0. So there are two answers that satisfy this equation, and that means there's two roots. One root is when t equals 0, and the other is when t equals 11. So those are the roots of this equation. Now, we also know that if we take the midpoint of the roots, we'll find the x-coordinate of the vertex. So again, our roots were at 0 and 11, so the midpoint is 0 plus 11 divided by 2, which is at 5.5. So when t equals 5.5, I have the vertex, which means I have the first coordinate of the vertex, the x, or in this case the t. I just don't know the second part. So now that I know the x-coordinate, if I sub the x-coordinate into the equation, I'll be able to calculate the y-coordinate. And again, in this question, we're specifically talking about t and h, but they're in the place of x and y. So now that I know that when t equals 5.5, I have the vertex, I'm going to sub 5.5 in for t. So the original equation said negative 5 times t, and then there was a bracket, and in the bracket was t minus 11. So I just have to do this math. H equals, oops, I lost my answer. So -5 times 5.5 times -5.5, because that's what's in that bracket, I get 151.25. So that means I know where the vertex is. So when t equals 5.5, the height is 151.25. Oops, that's a decimal, that's a comma. So here's what I know. I know the height, I know the roots, and I know the vertex. Is there anything else I can find that will help me make a good sketch? Well, we could find the y-intercept. So to find a y-intercept, we let x equal 0. But if you haven't already noticed, that's sort of silly to do in this case. If I let x, or in this case t, be 0, oops, I get 0. So the y-intercept is at 0, 0. Well, I already knew that, because if I let x equal 0, I get y equals 0. It's a point I already know. So when you have the point 0, 0 in a relationship, you have both an x-intercept and the y-intercept. Ooh, and if you draw this, it kind of looks like the start of a little cartoon dude. Anyway, so let's go ahead and try to sketch this. So I've already started building a graph, and you'll notice I'm not using any negative values for time or negative values for height, because in this context, a lava flying in the air over time, negatives just don't make sense. Now, across the t-axis, can I get to 11? Let's see. Let me grab a different color pen. So here's 5, here's 10, that would be 15. So yeah, I can definitely use just a nice simple scale here for time. Now for height, I need to get to 151, so obviously I'm going to scale it. Let's call this 50, 100, 150, and then that way I can fit all my nice points on it. So what points do we have? So we know that 0, 0 and 11, 0 are the roots, and we know that the vertex is at 5.5 and 151, so just past here. And now I just have to draw a decent parabola. Now this is a really hard thing to do with my tablet. I'm pretty good on the chalkboard, but bear with me as I try to draw a reasonably accurately shaped. So, you know, my symmetry is bad. I got these wobbles, but whatever. You get the idea, right? There's a somewhat nice graph representing the height of lava versus time. So I just want to make sure that I complete this graph so that if you're following this example, you're not going to lose any marks because I didn't do something your teacher expected. So time is in seconds, height is in meters. I've got labels, I've got little arrows over here. I got a title. Okay, I'm happy. So we did part A, sketch a graph of the relation. Then it says find the maximum height reached by the lava. Well, I know that already. That's the vertex. So the maximum height was 151.3 meters if I round to the nearest meter. Oh, actually, if I round to the nearest meter, it's 151 meters, so no decimal. How long does it take the lava to reach maximum height? Well, it takes that many seconds, so it takes 5.5 seconds to reach maximum height. So I've done A, B, and C, so let's look carefully at D. Is the length of time the lava is in the air twice the answer from part C? Explain why or why not. So my answer to part C was 5.5 seconds. So 2 times that would be 11. So that's what I'm looking for. So is the length of time that the lava is in the air 11 seconds? Well, yes, it is. If you look at this graph, so I used a graphing program free on the internet and awesome called Desmos to graph this parabola for me. And that's how long it was in the air, at 11 seconds. Now 11 seconds is exactly twice 5.5 seconds. So it is in the air. So yes, the lava is in the air for twice the time it takes to get maximum height. Now a better thing to explain is, why is that true, or why is that interesting? Well, because we know that we have symmetry in every parabolic graph, in every parabola, we know that there is this nice, well, if it takes 5.5 seconds to get to maximum height, then another 5.5 seconds it'll hit the ground. The problem is that's not true in every case. In fact, it's only true if 0, 0 is part of your graph. So let's just give another example here to make that clear. The graph on the left, 0, 0, is part of the function or the relation. On the graph on the right, it does not pass through 0, 0. And so what I want you to notice is on the left, where we do pass through 0, 0, the axis of symmetry, which passes through the vertex, is exactly halfway between our two roots, and therefore, since 0, 0 is a root, I can just take the time it would take to get to vertex and double it to get to that intercept. But the graph on the right, we still have the axis of symmetry halfway between the vertices, between the roots, but because the graph doesn't actually start at this negative intercept, the graph would start here if this was a projectile motion question. The time it would take to get to maximum height is not just the same as the time it takes then to land the ground, and that's because the symmetry is with the roots, not with the starting value, if the starting value is not at 0, 0. So I hope that helps a little bit make sense of that situation. I hope this video helps, and go do some math. Thanks for watching.